homework.
Oh, no, let's see, no.
No?
Not that I can see on here, unless it got sent to my spam, no.
Oh, okay. Here, let me give him a call real fast, because he has it on his phone.
Okay.
Alright, just a sec.
Or are they problems you can verbalize?
What's that?
Are they problems that you can verbalize?
Yeah, probably. It'd be kind of difficult.
Unless they're graphical in nature. In other words, if we have to read graphs, then it's hard to verbalize them. But
yeah, it's arithmetic sequences.
I think we can verbalize those.
Okay, yeah, we can just do that then.
Let's try.
Okay.
So we got an arithmetic sequence.
Yeah.
Okay.
Okay.
What's the first
it says describe the graph of an arithmetic sequence.
That's it?
Uh-huh.
Okay.
Yeah.
What is an arithmetic sequence? Is a sequence of numbers that are all separated by the same amount.
Okay.
In other words, they all have a common difference. What's the next term?
Here, just a sec. Okay. The next one is, write the next three terms of the arithmetic sequence, so...
Oh, hold it. In the sequence that I've drawn on my page, what's the next?
Oh, my bad. 13.
Okay, and the next term after that?
16.
Okay, so the common difference is 3.
Yeah.
Okay, and there's a formula that tells you what is the nth term.
Okay.
The nth term is the first term plus the common difference times the number of terms minus 1. You want to memorize that.
Okay.
Okay. Notice that if I wanted the fifth term of this sequence, a sub 5,
yeah,
I would plug in the first term, which is 1, plus the common difference, that's 3. It's the fifth term, so my n is 5.
Okay.
That is 3 times 4, which is 12, plus 1, that's 13.
Okay.
So this nth term can give you, if I said what is the 400th term in this sequence, well, it'd be hard to write out 400 terms, right?
Yeah, it would.
But we could do it easily if we knew that formula.
Okay.
In other words, d would still be 3, a sub 1 would still be 1, but n would be 400, and then whatever we get is the answer. So that's the essence of arithmetic sequences, and this is the thing you want to memorize right here.
Okay.
Okay. Now let's do the problems you have to do. What is it asking?
Let's see. So the next one is
hold on.
The
very first question I forgot to answer, and that is what does the graph of an arithmetic sequence look like?
It'd be like a linear graph.
It's linear.
Like a straight line.
Exactly. Because no matter if, in other words, if this is n, the first term was 1, the second term was 4, the third term was 7, that ends up being linear. Because every time n increases by 1, y increases by 3. Well, that's the characteristic of a linear equation.
Okay, cool.
Okay, so that's the answer to that. What's the next question they got there?
The next one is, so the first term is 18, and the common difference is -6.
What do they want to know?
So you just have to find the first 3 terms.
Okay.
So 18 minus 6, so that'd be 12. 12, 6, and then 0.
So the first term is 18, second term is 12, third term is 6, fourth term is 0, fifth term is -6. Okay?
Okay.
What else they got?
Cool. And then the next one, find the common difference of an arithmetic sequence. So it goes 13, 18, 23, 28.
Goes what?
It goes up by
13, 18, 25. What's the fourth term?
23, 28, 36.
Hold on.
Because it goes up by 8 each time.
Well, then it's not 13, 18. In other words, the key to an arithmetic sequence is that every term has to be separated by the same amount.
Oh, so there is no arithmetic sequence.
Well, the one you gave me was not. If it's 13, 18, 25, that's not an arithmetic sequence because that's a difference of 5, that's a difference of 7.
Yeah, that's not right.
So it has to be a common difference to be an arithmetic sequence. There's lots of different kinds of sequence. There's also geometric, which you'll learn next.
Yeah.
But arithmetic sequences all have to have every number separated by the same amount.
Okay. Cool.
So what do you got next?
The next one is 175, 150, 125, 100.
What are they
So
at?
it goes down. Yeah, sorry, it goes down 25.
So D is minus 25.
Yeah.
Okay, that's all they want to know?
And then the three terms.
Oh, the three next terms?
Never mind. Yeah, I was looking at the wrong one.
What are they?
75, 50, and then 25.
Okay.
Cool.
Okay.
Alright. Then the next one would be negative 16, negative 12, negative 8, negative 4.
What's the common difference?
Goes up 4.
What's the next three terms?
4, 3 and 2/3.
Don't forget
4, 10.
Hold on. The next term
my bad.
is 0. We got to add 4 to minus 4.
Yeah, so it'd be 0, 4, 8. Yeah, 0, 4, and 8.
Okay.
Cool. Alright. And then the next one is 4. 3 and 2/3. 3 and 1/3. And then 3.
What's the common difference?
It would be 1/3.
Plus or minus?
Oh yeah. So D equals
It's minus 1/3.
minus 1/3.
In
Okay.
other words, you have to subtract 1/3 to get from 4 to 3 and 2/3. You have to subtract another third to get to there, and another third to get to there.
Okay.
Okay, what's the next three terms?
2 and 2/3, 2 and 1/3, and then 2.
Okay.
Alright. The next one is 6.5, 5, 3.5, then 2.
Common difference?
Distance, sorry. Would it be 1.5?
Don't forget the sign. The sign's very important.
Yeah, negative 1.5.
Yeah, because if it was 1.5, the second term would be 8. It'd be going up. Exactly.
Okay.
Now, what's the next three terms?
2 should be 1.5.
No, just 0.5.
Or just 0.5. Negative 2.5.
Negative 1.
Negative 1. Negative 3.5.
Negative 2.5.
2.5, yeah.
All right, let's go back and look at that again because you had a little trouble with that.
Okay.
I'm subtracting 1.5 from each of these numbers.
Yeah.
Okay? So when I got down to 2, what is 2 minus 1.5?
2 minus 1.5. 0.5.
That's how we got that.
Okay.
Now to get the next number, I'm going to do 0.5 minus 1.5.
And then that'd be negative 2.
That's negative 1.
-1, my bad.
That's like 1/2 minus 1.5.
Okay.
The halves take care of each other, and I'm left with -1, and that's how we got that.
Okay.
And then, let's just make sure you know your algebra here. -1 minus 1.5. That's minus 2.5.
Minus 2.5, yeah.
Okay. In other words,
because a negative and a negative is a positive.
Well, the way to do that problem is to turn all your subtraction problems into addition problems.
Okay.
Okay, and the way you do that is you change the subtraction sign to a plus, and then you change the sign of the number that was being subtracted.
Okay.
So now it becomes -1 plus a minus 1.5. Well, we know how to add two negative numbers. You just add the numbers and you attach the same sign. So that's minus 2.5.
Okay, cool.
Okay?
All right.
Okay.
The next one is -16, -7, +2, and then 11.
Common difference?
-9, or +9, my bad.
The next
equals 9.
Next three terms?
20, 29, then 38.
It's easier when D is positive, for sure.
Yeah, it is.
Okay, what else we got?
Alright, so now it says write the next three terms of the arithmetic sequence. Same thing. So 19, 22, 25, 28. And it'd be D equals 3.
The next three terms?
31, 34, 37.
Okay. Let's jump ahead to problems that you don't know how to do.
Okay.
Because you know how to do these.
Yeah.
Or let's jump ahead to the next type of problem.
Mm-hmm.
Let me give you one.
Okay.
Okay, this is an arithmetic sequence
Okay.
where I've given you the first term and I've given you the common difference.
Okay.
What's the sixth term? And do it by this formula, not by counting them out.
Okay.
We could do it this way. 3 plus, each one's going up by 2. So it'd be 2, 7, 9, 11, 13. So we know that's the answer. But let's see if we can get it by this formula.
Okay.
So A sub 6 would be what?
A of 6 would equal...
It's called A sub 6. It's not A of 6, just because of is usually referred to like that, A of 6.
Okay.
But when it's a subscript, like this, it's A sub 6.
Okay.
And in this case, it's equal to what? 3
plus 2. Yeah.
What's in?
6 minus 1.
So by that formula, we can figure out what any term is, no matter how big it is.
Okay.
Just by substituting, as long as you know the first term and the common difference.
Okay.
Okay, go ahead and find one to give to me. I just made that one.
Okay. Like one from my sheet.
Yeah.
Okay. So the arithmetic sequence is 1, 12, 23, 34.
Okay, what are you supposed to do?
It just says find the next three terms.
Okay, so these are still, is that all you have on your sheet, is problems like this?
Yeah, so there are 5 more of those, and then,
What comes
it
after?
says graph, so graph the arithmetic sequence.
Okay, graphing these things, not all that useful. Let's graph that.
Okay.
What's the horizontal axis?
X.
Actually, it's
So,
N.
or N, yeah.
And
Okay.
the vertical sequence is
It's
A.
A then. Okay.
Okay, so when N is 1, what is A sub N?
So, would it be also, I don't know this.
It's 1.
1. 1, yeah.
Right, we can see it. A sub 1 is 1.
Okay.
Okay, when N is 2, what is A sub N?
2.
Look at the sequence. What's
So
the second term of the sequence?
12.
Okay, so it's 12.
Okay.
Okay, if they want us to graph it, this is the way we got to do it.
Yeah.
When N is 3, what is A sub N?
23.
Okay, way up there. We'll notice that that's a straight line.
Yeah.
We could keep going, but I'm not sure what purpose it serves. The thing to understand is that arithmetic sequences always graph as straight lines.
Okay.
Okay, and the N is your horizontal axis, being the number of the term, and the vertical axis is A sub N,
Okay.
which is the nth term. In other words, people get confused by this terminology. Nth term. That just means whatever term in the sequence. In other words, if I want the 4th, what is A sub 4 in this sequence?
Also 4. Oh, 34. 34.
Okay, what's A sub 5?
45.
Okay, what's A sub 6?
56.
And A sub 7.
67.
There's your next 3 terms.
Okay. Cool. Yeah, then, that's it actually on the homework. Just that stuff.
Okay. So, you haven't done geometric sequences yet, right?
No, not yet.
Have you done sums of arithmetic sequence?
No, not yet.
Okay, both of those are coming up next.
Yeah.
You're going to do the sum of an arithmetic sequence, and then you're going to go into geometric sequences, and then you're going to talk. A geometric sequence, just a little bit of a header, means that every term is a multiple of the previous term.
Okay.
Notice that that is not an arithmetic sequence, right?
Yeah.
But it is a geometric sequence. Why? Because that's 2 times the previous term. That's 2 times 4, and that's 2 times 8.
Okay.
So when you talk about geometric sequences, you're not talking about a common difference. You're talking about a common ratio.
Okay.
You have this thing called R.
Okay.
And R is like D, only, and you have a different nth term formula also. The formula that I showed you originally is just for arithmetic sequences.
Okay.
Geometric sequences has the form A sub n equals the first term times the common ratio to the n minus 1 power.
Okay.
Notice what the 4th term would be by this formula. What would it be? What's A sub 1?
So it'd be A sub 1.
What's A sub 1?
16.
No, what's A sub 1 in my sequence?
Oh, 2.
Okay, so that's what I plug in for A sub 1. What's R?
Then R would be 4.
Hold on.
Or R equal, oh, okay, R equals 2.
You get R by dividing any term by the previous term. You can pick any term in the sequence and divide it by the previous term, and you always get 2.
Okay.
So R is 2. I'm going to raise it to the n minus 1 power. Well, n is 4, so n minus 1 would be 4 minus 1. So now we're talking 2 times 2 cubed. Well, 2 cubed is 8. That's 16. That is indeed the fourth term.
Okay, cool.
So if I said, what is the 100th term? It'd be hard to do it if you didn't know this formula.
Yeah, it would.
But if you know that formula, then a sub 100 is 2, the first term, times the common ratio 2, raised to the 99th power. N minus 1. And of course, 2 to the 99th power, as you probably know, is a humongous number.
It is. Yeah.
Your calculator might even cough if you tried getting that number in your calculator.
Yeah.
It might spit up all over you.
Yeah, seriously.
Okay.
All right.
So what else do you want to cover tonight?
That's actually it, just the arithmetic sequence.
I think the pronunciation is arithmetic.
Yeah.
Maybe not. Is your teacher saying arithmetic sequence, or is she saying arithmetic?
Yeah, she's saying arithmetic.
She is.
Yeah.
You know, I might be wrong. I've always called it arithmetic, but maybe they're pronouncing it arithmetic now.
There are probably two ways to say it. I mean...
Yeah, because when you get to geometric, it's not going to be a geometric.
Yeah.
Geometric. In other words, the emphasis is on the met.
Yeah.
Like the arithmetic. Arithmetic. So I think arithmetic is correct, but if she's saying arithmetic, then don't change it. You don't want to go out there and start calling it something that she hasn't been calling it. So.
Yeah.
All right.
Okay.
We will end it for tonight and pick up next time. Let me just check my schedule real quick. Let's see. It looks like you got nothing scheduled the rest of this week.
Okay. Yeah.
Okay?
Okay. Awesome.
Sounds good, Dylan. Have a good week.
All right. Sounds good. Thanks, you too. All right.